Hello everyone, welcome back to my channel Explain Maths. Now in this video, I will be solving the questions given in exercise 11.1 of the topic direct and inverse proportions. Okay, so let's begin the class. Question number 1. Following are the car parking charges near a railway station. And these are the charges given. You have to check if the parking charges are in direct proportion to the parking time or not. So to check whether parking charges are in direct proportion to time or not, we have to find the ratio in each case, right? And then only we can check whether they are in direct proportion or not. Because if ratios are same throughout, we can say that they are in direct proportion. So let's first tabulate the data. Now I'm going to find the ratio one by one. So first is 4 by 60. So it will be 4 times 1, 4 times 15. So here I will get 1 by 15. Second case. 4 times 2 is 8 and 4 times 25 is 100. So it will be 2 by 25. Third case, 4 times 3 is 12 and 4 times 35 is 140. So it is 3 by 35. And the last case, 6 times 4 is 24. 6 times 30 is 180. 2 twos are 4. 2 times 15. So it is 2 by 15. So if you see here in each case, the ratios are not same, right? They are not constant, they are different. So we can say that the parking charges are not in direct proportion to the parking time. Question number 2. A mixture of paint is prepared by mixing 1 part of red pigments with 8 parts of base. In the following table, find the parts of base that need to be added. So here if you see how a paint is prepared by mixing the part of red pigment with the part of the base, and you have to find if part of the red pigment is 4, then what will be the part of base. So clearly you can see here this is a case of direct proportion, because as you will increase the part of red pigment, the part of base will also increase, right? And we know that in a direct proportion what happens, the ratio remains constant, the ratio remains same for all the cases. So first, to find the part of base here, when the part of red pigment is 4, I am assuming it as y1. And then as it is a direct proportion, so from here I can write 1 by 8 will be equal to 4 by y1. Isn't it? 1 by 8 will be equal to 4 by y1. And when I do cross multiplication, so 1 into y1 will be y1 and 4 into 8 will give me 32. So in the first case, the value of y1 is 32. Now next I am going to assume the second part of base as y2 when the part of red pigment is 7. So again what I am going to use, 1 by 8 is equal to 7 by y2. And when I do cross multiplication, y2 will be equal to 7 into 8 and 7 into 8 is 56. Now same way I am considering the another one as y3, and again I can write 1 by 8 is equal to 12 by y3. So from here I can get y3 is equal to 12 into 8, and 12 into 8 is 96. The last one, 1 by 8 is equal to 20 by y4, and the value of y4 will be 20 into 8, which is equal to 160. And you can see clearly from here, as the part of the red pigment increases, the part of base is also increasing. Y1 is 32, right? So from 8 it increased to 32, and y2 is 56. Same way y3 is 96 and y4 is 160. So as the part of the red pigment is increases from 1 to 4, 4 to 7, 7 to 12 and 12 to 20, the part of base also increases, isn't it? So this is your question number 2. And if you like my content, please subscribe to my channel and share with your friends also, such that they can also get benefit from my content. Now question number 3. In question 2 above, if one part of a red pigment requires 75 ml of base, how much red pigment should we mix with 1800 ml of base? Now this is a continuation of the second question. Now here it is given if one part of a red pigment requires 75 ml of base. In the previous question, both were given in parts only, but here it is base is given in milliliter. and you have to find how much red pigment should be mixed with 1800 milliliter of base. So I will assume let the part of red pigment needed be X, and let's tabulate it. So when part of red pigment is 1, the part of base in ml is 75, and you have to find when part of base is 1800 ml, what will be the part of red pigment. So again we know that here the red pigment and the part of the base both are in direct proportion, right? As the part of red pigment will increase, part of base will also increase. And in direct proportion we know that ratio will be constant. So here what I will write, 1 by 75 will be equal to x by 1800. And now I will do the cross multiplication. So from here I will get 75 into x will be equal to 1800, and when we solve it, the value of x will be 1800 divided by 75. So now I will use 5 tables. So 5 times 15, and this will give me 5 times 360, and then 15 table, 15 times 24 will give me 360. So from here we can see that the part of the red pigment is needed is 24. Question number 4. A machine in a soft drink factory fills 840 bottles in 6 hours. How many bottles will it fill in 5 hours? So here if you see, if a machine has to fill more number of bottles, obviously the time taken will be more. And if it has to fill less number of bottles, the time taken will be less. So this is a case of direct proportion. As the increase in one quantity increases the other quantity, and decrease in one quantity decreases the other quantity. So I will assume let the number of bottles filled by machine in 5 hours be X. As it is a case of direct proportion, because number of bottle and time taken to fill the bottle are in direct proportion. So what we can say, the ratio will be constant, means the ratio will be same in each case. So from here I can write 840 by 6 will be equal to x by 5. Now do the cross multiplication. So 6 into x will be equal to 840 into 5. So the value of x is going to be 840 into 5 divided by 6. And now reduce it. So from here you will get 140 into 5, and 140 into 5 is 700. So the value of x is 700 bottles. Okay, so the machine can fill 700 bottles in 5 hours. Now question number 5. A photograph of a bacteria enlarged 50,000 times attains a length of 5 centimeter as shown in the diagram. What is the actual length of the bacteria? And there is another question. If the photograph is enlarged 20,000 times only, what would be its enlarged length? So we'll find out one by one. So this is the picture of a bacteria given, and it is given in the question. If you enlarge it 50,000 times, then the length of the bacteria will become 5 centimeter. Now you have to find what is the actual length of bacteria. Means when you did not do any enlargement, then what is the length of the bacteria, right? It means when you did not enlarge it, it means the number of times here it will be 1, because you didn't enlarge it any time. So it is in the original shape only. Okay, there is no enlargement. Whatever is given in the photo, it is as it is. So now I am going to assume the actual length of the bacteria be X over here. So again, it is a case of direct proportion, because when you increase the enlargement number of times, accordingly the length of the bacteria will increase. And if you decrease it, the length of the bacteria will decrease. So this is a case of direct proportion. So, and we know that in a direct proportion, the ratio remains constant, right? So from here I can write 50,000 by 5 will be equal to 50,000 by 5 is equal to 1 by x, and when you do cross multiplication, it will become 50,000 into x equal to 1 into 5, and 1 into 5 is 5 only. So the value of x will be 5 by 50,000, and when you reduce it, it will be 1 by 10,000, and 10,000 I can write as 1 by 10 to the power 4, and which can be further written as 10 to the power minus 4. You have already studied negative exponents, right? So 1 by 10 to the power 4 we can write as 10 to the power minus 4, and it is in centimeter. So from here I have got my actual length of the bacteria is 10 to the power minus 4 centimeter. And when you enlarge it 50,000 times, it becomes 5 centimeter. So you can see from here, when the number of times increase from 1 to 50,000, what you can see here, the length of the bacteria is 5 centimeter, isn't it? So now what you have to find, when the photograph is enlarged 20,000 times, then what would be its enlarged length? So I'm assuming my enlarged length be y over here. So again I am going, as it is in direct proportion, so again I can say that the ratio will be constant. It will be same, right? So 50,000 by 5 will be equal to 20,000 by y. And if I do cross multiplication, it will be 50,000 into y will be equal to 20,000 into 5. And the value of y will be 20,000 into 5 divided by 50,000. Okay, so 4 zeros I can cancel out. Then 5 times 1, 5 times 1. So I am left with y value as 2 centimeter. So when the photograph of bacteria is enlarged to 20,000 times, the length of the bacteria will be 2 centimeter. Okay, so this is your question number 5. Now question number 6. In a model of a ship, the mast is 9 centimeter high, while the mast of the actual ship is 12 meter high. If the length of the ship is 28 meter, how long is the model ship? So here it is given in the model ship, if the mast is 9 centimeter high, this is the mast. When this is 9 centimeter high in model ship, in the actual ship actually it is 12 meter high. So same way, if the length of the ship is 28 meter, okay, if the actual length of the ship is 28 meter, how long is the length of the model ship you have to find. So here also if you see, whenever you make a model of something, isn't it? So it is in proportion of the actual thing, right? So here also you can say that this is in direct proportion. So I'm assuming the length of the model should be x. And when I'm tabulating it data over here, you can see the model ship is in centimeter and actual ship measurement is given in meter. And model ship and actual ship, it will always be in proportion. So whatever you have to make, actually when you are making it in a form of a model, it is always be in proportion. Okay. So the length of the model ship is directly proportional to the actual ship. So from here we can write 9 by 12 will be equal to x by 28, because in direct proportion we know that the ratio will be same, right? They will be constant. So 9 by 12 will be equal to x by 28. And let's do the cross multiplication. So 12 into x will be equal to 9 into 28. So the value of x will be equal to 9 into 28 divided by 12. And let's reduce it. So 3 3s are 9, 3 4s are 12, and 4 times 7 is 28. So from here I can get 3 into 7, which will give me 21 centimeter. So the length of the model ship will be 21 centimeter. So this is your question number 6. So that's all for today's class. If you like my content, please share with your friend. Thank you.